Good morning, good afternoon, good evening. Thanks for joining this instance of the Antrea community meeting. Today is Tuesday, February 27th. Of course, unless you are in the United States, in that case, it will still be Monday for you. And we don't have much on the agenda, but we have a presentation from Anju, I believe, for today. Let me verify. Yes, that should be right. And this presentation should be around running flexible IPAM tests on kind. So please go ahead and let's get started with today's meeting.
Yeah, okay. Thank you, sir. Let me share my screen. Okay. Can you see my screen?
Yes.
Okay. So, hello everyone. So today I will share few slides on the topic entry of flexible IPM with a kind cluster. So let's get started. Okay. So, here I have listed a few points about the entry of flexible IPM feature. The first is Antrea supports flexible control over port IP addressing. That means user can create IP pool and specify the IP ranges in the IP pool. And when Antrea agent receive the request add, then it will allocate the IP to the ports from that created IP pool. So when port's IP is allocated from IP pool, the traffic from port to port on another node or from port to external network will be sent to the underlay network through the node interface. And this forwarding we called bridging mode because communication will happen via the bridge. And in the IP pool, we can provide set of IP ranges and VLAN ID. And in IP pool, we can annotate to the namespace, port template, or stateful set or deployment. And Entria will manage the IP assignment based on the IP pool specification that you have provided. And IP pool annotation cannot be updated or deleted without recreating the resources. And IP pool ranges we can extend, but we cannot shrunk if assigned to the resources. The IP ranges must not overlap, otherwise it will show the error or undefined behavior. And if you want to enable this feature, then you have to enable it from the Antrea config file. So in the controller feature gate, you have to set entry IPM true, and entry agent feature gate set entry IPM true, and then enable the bridging mode, and traffic mode will be no in cap, and there will be no snap. In the IP pool, you can specify the IP ranges, gateway IP, prefix length, and VLAN ID. So if you are not providing VLAN ID, then it will consider as a default network or untagged network. In the namespace, you can provide, you can in the annotation field, you can provide the pool name, and but you can provide only single pool. You cannot annotate with the multiple pool on the namespace. Okay, so running Antrea flexible IPM E2E test in kind cluster. So here we have a trigger phrase for this job. So if someone wants to run flexible IPM E2E test with their GitHub PR, then they can trigger this test using test kind flexible IPM E2E trigger phase on the PR. And workflow will be like in the right side, you can see the first it will create the kind cluster, then it will create the VLAN sub interfaces with the Linux bridge or kind bridge to pass the VLAN traffic. Then apply the entry YAML, and after that it will run the E2E test, and after finishing the test it will delete the kind cluster, and after that it will delete the sub interfaces from the bridge. Because this is the IPAM feature, so we have few requirements for this. The first requirement is IP pool in the IPs in the IP pool without VLAN must be in the same underlay subnet as the node IP. And second is IP pool with VLAN must not overlap with others network subnet. It should be in unique range. And third point is underlay network router should provide the network connectivity for these VLANs. So for this we are using VLAN trunking. And we know that like Docker create kind default network is in 172 range, but our IPAM ports without VLAN are in 192 range. And so according to the first requirement, we need our kind network is in 192 range. So let's see how we gonna do that. Okay. So like when we run kind create cluster command, then Docker first will check if there is any kind network exist. If kind network exists, then it will create the kind containers and connect to that existing network. But if the network kind network doesn't exist on the system, then it will first create the kind network is in default subnet, that is in 172 range. After that, it will create the kind container and attach to that 172 network. But we need our network in 172 range. So what we gonna do? In case of kind IPAM case, what we first create the kind network. So like I have allocated a dedicated VM for this. So there I first I'll create the bridge or kind network. After that, we are creating kind cluster. So when we run this command, then kind will use the existing kind network that is in 192 range. And after that, it will create the containers and attach to that network. So nodes will get the IP in 192 range. After that, it will create sub interfaces on the bridge. And after that, run the IPAM test on the kind cluster. And after finishing the test, it will delete the cluster and it will delete the sub interfaces from the bridge. Okay, so here I have made a simple diagram to understand VLAN interface or connection. So this is the bridge, or we call it Linux bridge or kind bridge. It created by container runtime like Docker. So this Linux bridge acts as a virtual switch, and it allow network packets to be uh, forwarded between different network interfaces. And this bridge supports VLAN trunking. VLAN trunking nothing but the configured this Linux bridge or kind bridge to handle VLAN tag traffic. So VLAN trunking allow you to create multiple VLAN sub interfaces on the existing Linux bridge with a unique VLAN tag, so that Linux bridge can forward packet between the VLAN interfaces based on their unique VLAN tag ID on the packets. So here we have two VLAN interfaces associated with their unique tag ID 11 and 12. And whenever a VLAN traffic comes to these VLAN sub interfaces, then these interfaces check with the Linux bridge. Linux bridge check the switching table, or it will check the VLAN tag on the packets, and based on that tag, it will send or forward the traffic to that particular VLAN interface. And if packets are untagged, so it will consider this is a default network packet, and it will send to the node interface. uh, uh, and after that, because we have some ports in default port cider that is in 10.44 range. So for that, we learn to communicate with these ports. We need to add the route for it on the VM. So for that, we have added a route, and if VLAN pods wants to communicate or wants to ping 10.244 ranges IP. So for this, it will go via the node interface. So I have added these routes on the VM, so we can check in the we will see in the demo. So can I go for the demo?
Good for me. Not sure if there are any questions.
Andrew, I have a question. I see for flexible IPAM case, you mentioned you have to create a separate Docker bridge.
Yes.
Why is that? Why can't we just use the default bridge? I think the only difference is subnet, right?
Yeah, so because we need all the nodes like controller plane and other nodes, worker nodes, we need all the nodes in same range, 192 range. So that's why I create
Which range do you mean?
192 range. In the test cases, they have provided some fixed range. So I'm using those ranges to run these tests.
Oh, you mean the test code itself assumes that the node IP is in a specific range.
Right.
Oh, I think maybe we could just change the test case to not assume that, or to discover the node IPs, so you don't have to have two bridges, one for normal kind cluster, one for flexible and pump. Because even in egress with VLAN, you and end-to-end test, I used the similar topology and just shared the default kind of bridge for VLAN. I think everything just works.
Okay, I'll check.
Yeah, so basically we have also like that also works but the only thing is like because test code was written in 192 subnet, so that was the reason to create Docker bridge into that subnet. Otherwise, that can also be taken as a solution.
I see.
Okay, let's go for the demo.
Sorry, I have a question related to the static routes. Can you go back to the previous page?
Yeah. Yes.
All these static routes are added to the VM itself.
Yes.
Okay. So if I want to talk to 1.244.1, which is a VLAN 11, I will go via the 192.168.240.2, which is the ETH0 IP on the current worker node. Is it
Yes, right. This is a node interface IP.
okay? So this interface is directly bridged to the BR9240 blah blah. So my question is like, can we use the sub interface IP as the next hop instead of the ETH0? Looks like if it's a VLAN inside, if we put the paths on the VLAN 11, it seems that if we go through the VLAN sub interface, maybe it's a more realistic simulation.
I think if the destination is port with VLAN, it doesn't go this route. It will go the default route that is not listed here, because the bridge itself has because the VLAN subnet is local to this bridge interface. So if the destination IP is in VLAN 11, it will go to the destination while the sub interface of VLAN 11 it doesn't hit any of the destination listed here. And when it arrives at the node, it physically it arrives at its zero interface, but logically it will. I think it is still with a VLAN tag, so will eventually be forwarded to OS and be untagged. That's my understanding.
So in the physical network, such traffic will be sent to the gateway, and then suppose gateway will route the traffic to the VLAN network, and somewhere there will be a switch who will tag the VLAN 11 to the traffic, and then the traffic will reach to ETH0 with the tag. So I'm thinking like, if the pod without VLAN traffic, without VLAN wants to talk to VLAN 11, should he send it to the VLAN sub interface on the bridge? That is my question. I'm not sure I explained. So in that way, the VLAN sub interface will add the VLAN 11 tag and send to the underlying bridge, and the underlying bridge send the traffic to the ETH0 with the tag.
Maybe Andrew can answer that, but my understanding is that if the traffic is will cross subnet, it will be forwarded. It will do a layer 3 forwarding by the underlying router, which is the bridge in this case, bridge interface in this case, because only the bridge interface connects to the two different subnets. And when it receives the traffic, it will have no tag. And when it leaves this interface, it will be tagged.
But if you send to the bridge interface directly, for example, the ETH0, because it's in the 240.0 network, it's in the same network as BR924. So yeah. I think the traffic between them, they are not tagged.
Yeah.
Yeah. So if we add the ETH0 for as the next hop, all the traffic will be sent without the tag.
But the destination is not in this CIDR, right?
The destination is in the route match part is the VLAN subnet. So the traffic will matching the VLAN subnet will be go through the node ETH0 eventually without the tag.
Without a tag, it will go like.
So maybe can we explore that, whether we can use the VLAN sub interface as the next hop? So in that case, maybe you will firstly go to the VLAN sub interface, and it act as like a router or gateway for you. Then I will add a tag, so maybe it will be more realistic.
I think the routes listed here is the routes configured on the bridge interface, not in the node's own network namespace. They are for the returning traffic to for traffic designated to port without VLAN. They are not added for port with VLAN. For port with VLAN, there is already an implicit route configured for each VLAN. If Andrew could share the route table in the demo, I believe there is one route for each VLAN already there. I think the three routes listed here are needed to be added explicitly, because this is a common requirement for no in-cap deployment. Because for no in-cap deployment, we automatically add root to nodes, but for external device, if there will be traffic from external, the external device needs to know the root for.
Oh, understood. Yeah, understood.
They are not
Thanks.
really specific to flexible IPAM. It's just
understood.
for
no
in-cap.
in-cap.
Yeah.
Understood. Thanks for the clarification. Now I understand. I have no question.
Thank you, John. Okay, let's the demo. Okay, so we don't have kind bridge. Edit. So I'm creating the network in 190 to 168 to 40 range. The kind network in the interface, we can see the gateway IP is this. This is the IP route. And let's give it the kind cluster. Okay, so I'm passing the CNI flag and kind name, VLAN subnets for the 11 and this is for 12. And VLAN IDs 11 and 12. Sorry. It will take some time. This is configuring first VLAN 11 with the sub interface. Then for the VLAN 12, this is sub interface on the bridge. Check the interface. So this is the Linux bridge or kind bridge, and this is the sub interfaces on the bridge. This is the gateway IP. This is the VLAN 12 sub interface, and the gateway IP is this. We can check the root. You can see I have added the code for it. It added automatically for the 10 ranges root, and these are the node pieces. Oops. we have all the nodes in 192 range. So let's check the connectivity. I have already created few pods. So check. So these are VLAN 11 pods I've already created, and these are VLAN 12 pods, and these are pods without VLAN. This is Antrea export test pods. Let's check the connectivity from the VLAN 11 pods. CubeSat. Oh, CubeSat. You can try to ping other VLAN, be like 12. So we can ping it, or we can ping this IPAM. Or for the 10 ranges, we can also ping, because we have added the route for it. Okay, so this. Okay, this is it that I wanted to share. I don't have anything else to share.
Thanks, Anju. And well, you already received quite a lot of questions, but let's see if there are more questions from the team for you. Wait a few more seconds. All right, it seems that it might be all for this. So thanks a lot for this presentation. That's going to be extremely useful for improving our CI and resource usage in our CI. Now we have also a second topic for today, and most specifically is about introducing BGP capabilities in the Antrea agent. It's a bit of a complex topic, and Hong Liang is going to talk to us about our design in this area, our ideas. Please, Hong Liang, go ahead.
Okay. I'll share my screen. Could you see my screen right now?
Yes.
Okay, thank you. Okay, let's just start it. First, maybe full screen is better. First, let's see the study design. For the name, I name it as BGP policy. And for the spec of the CRD, we have four main parts of the spec. But the first one is the node selector. This is used to select the target Kubernetes nodes. Another one is the AS number used by BGP protocol. This is mandatory. For the third one, we have different selector to select IPs outsiders. We will advise the decider of IPs to the remote BGP peers. We have some discussion where email with Chen, Jianjun, and Anthony. After discussion, for now we have these selectors. We have three service selectors like class IP, external IP, and then load balancer IP. each selector has the same structure. One is for select a service and a service selector. Another one is the namespace selector. And as you can see, that's literally we say we select the cluster IPs, external IPs, and the load balancer IPs. For this one, we use this is a Boolean type. We use temporarily adjust for we plan to do the first in the first phase. We just want to advertise the node IPAM pod sliders. In the future, we plan to advertise the IPs from Antrea IPAM. But that's maybe another complete complex feature. We don't we don't discuss further here. For this one is the egress selector. It doesn't have a namespace selector. It just select egress CRs and obtain its egress IPs and then advertise these IPs. For BGP peers, it's a slice or array, and it can include multiple BGP remote peers. These peers, like the main part is about the address port, yes, S number, and our secret. That's the main part.
Yeah.
We can. Oh, sorry.
I have a question regarding advertisement. I remember Jinjin suggested that if there's no requirement, perhaps we could just use we could just advise all service IPs. I mean, each type of class IP, service IPs individually. There could still be 3 types: class IPs, external IPs, load balancers. But perhaps there is no need to have a service selector and a namespace selector if there's no real use case for this. And at least for egress IPs, I think there should be no reason why some egress should be advertised while the others should not. So I think it falls into Boolean as well. But I don't have strong opinions regarding service IPs. Maybe Jinjin have more comments on this. I just feel that if no real use case, perhaps we could go with a simple way first, and it may look more unified if they have the same format.
Yes, I agree. I also think so that probably makes sense only for cluster IP. That's my feeling. And for egress, load balancer IP, external IP, I feel in most cases probably want to advertise all the IPs. And in that case, just to make the implementation simpler, I'm just thinking maybe we start from no selector at all. Hongliang, if you also agree, the implementing can be simpler if we don't support selector.
I'm fine with that. I think that would be much easier, much simple to use. You mean that we just use a Boolean type for external IPs and load balancer IPs? Is that right?
Actually, I'm saying for any type of IPs, we just advertise all the IPs if the type is specified in the BGP policy.
Okay,
and there's no selector.
Got that. That would be much simple. That would be much simple to use. Okay. Then I'll continue to. This
Sorry,
some
I have
example. Oh, sorry.
I have a question about CID. For example, if we want to advertise the cluster IPs, in the cluster IP, actually can be reached from any node. So if we select the subset of the Kubernetes nodes, which means that where any of the node, this cluster IP can be reachable from the outside. In case we advertise those routes. Yes.
Yes. I will show
Well,
some example about that.
will that generate the issue that maybe some traffic they are stateful? For example, TCP connection established to one of the cluster IPs via one node, and then you may need to assume that the upstream router they recognize the equal cost routes and the states.
Yes.
Okay, sure.
I have thought of that because we should assume that the upstream router have like something like a connection sticky for the
Okay.
for the package from connection. They should be forwarded. They should be always in one in your node, not like from multi nodes. That would in that case the connection will be broken.
Understood. And for the other types of IPs, for example, external IP, load balance IP, POP IP, QGRAS IP, they actually they are assigned to specific node. So I assume that only the node who is assigned external IP will advertise the BGP. Yes. Also
I have
egress
thought,
IP.
I have thought of that for class IP. They should be advertised in all nodes, and for egress IP, they will be only advertised in a single node and pod IPs. For
okay.
external nodes and load balancer nodes, I'm not properly I'm not totally confirmed that if but in my original thought, I think we will advertise the three all of service IPs from all nodes.
Understood. And then you will leverage that, for example, load balance IP. When traffic reach to a different node, then the load balance IP is assigned. Actually, on that node, it can also process that load balance IP.
I thought of
technically external IPs and load balance IPs can be advertised from every node. I think the QProxy implementation and the Antrea proxy implementation can handle the traffic to these endpoints. Even
yeah, but
how
about the ARP packets? Do they answer?
I thought I changed that as a result, in current implementation in my POC code, advertise all service IPs in all nodes.
If it's
Understood.
BGP, we don't need
no
ARP
is needed.
Zhengsheng.
Yeah, understood. No ARP is needed. Understood. Thanks.
Okay. Could we continue right now? Okay. As we discussed before, these examples. I didn't demonstrate all the attributes of BGP peers in previous slide. We have more attributes like BGP for BGP. Which are defined in RFC documents. Like this, we can. I think maybe this can be discussed in coding encoding states. In current design, I thought of that a BCP policy can be applied to like this, and it can be like this. It can be applied to one or two multiple nodes, and I'm sorry. And with your node, the BCP with distinct AS numbers can be effective at the front at the same time, but for the BCP policies that have the same AS number, only the first one will be effective, and the others serve as alternatives. If this one want to be effective, only it can be only effective when BCP policy BP 1-1 was removed, then this BP policy BP 1-2 will take effect. And as we can see, a BCP policy.
I have a question regarding ASN. What's the use case of applying more than one BGP policy to a single node with different ANS numbers? What's the use case here? I don't quite I'm not well familiar with BGP, so maybe a silly question.
In fact, I'm not totally sure that if we have such case. For example, we want to advertise port setters to a peer A, and we want to advertise service IPs to peer B. So we need to use two BGP policies on a node.
You mean it's technically possible and perhaps useful use case, advertising different IPs using different local ASN to different remote ASN.
Yeah.
Okay.
I'm not totally sure if it is meaningful. So I just we can maybe.
Does any other implementation support this scenario?
I saw that Selim has such implementation, but they don't like us because they for their implementation, every node of them can be only applied one BGP policy, but they can have multiple. They call the water router. Every water router can have distinct S number and BGP peers.
I see.
Hongyang, just one thing, like for example, let's say I have a BGP policy, and that is applied, and it is sorry, it is advertising some routes, as you said, that IP pool, and so that is advertised, and so BGP stack is there, like it is advertised, right? And so it has advertised those routes. Now apply another policy, so that will kind of, as you said, right? It will advertise, let's say, service sider, right? So in that case, because since already the old policy is gone, and now we have a BGP policy 2. So the what will happen is the BGP stack is going to discard the old advertised route, which was advertised by, let's say, BGP policy 1, right? So in this, like, what will be the meaningful of having multiple BGP policies, right? So at the BGP stack is going to cater to one BGP policy and advertised. So the old routes which were advertised, that is not going to stay in the neighbor, right? So in the neighbor synchronization, it is not going to hold the old routes, right? So I think
sorry, could you repeat that one? Some?
Okay, so yeah, so BGP stack is like it is like having some timers, right? Like graceful restart and all, and it keep on kind of
yeah.
syncing the routes from the neighbor, right? So in that scenario,
sorry.
yeah, right.
We only advise in our design, we only advertise our routes, and we don't install any routes for the routes learned from remote BGP peers. So is that
So yeah, so what I was telling that like at one point of time, the BGP stack running on that particular node, that will cater to only one BGP policy, right? It is not going to honor the old BGP policy which was applied. So those routes which will be there advertised already previously, those will be removed, which was advertised on the same node. So the whole idea of having multiple BGP policy is like as you mentioned, right? Like it is having like advertised some other routes which was advertised earlier, as well as the other policy which was advertising some other routes. So at one point of time, it will have only one BGP policy applied, and those routes will be only intact. So other routes which were advertised earlier, those will be kind of removed from the neighbor, right? Like after advertisement.
Maybe this
yeah.
this is a little complex. Maybe we can discuss this offline.
Yeah, because those timers which are there in BGP policy, right? So those make sure that like route get refreshed at a particular interval. So yeah, so it will only kind of honor BGP policy at that point of time. So
okay. Maybe this is a little complex. We can discuss from mail. Let's just start next. For data path, we use Go BGP. This is an open source BGP implementation, and it supplies Go libraries. We don't need to install any binary program like Bird or FRR. And we can just use Go libraries and integrate it into Antrea binary file.
For Hong Liang, have we compared the feature set between Go BGP and Bird?
In fact, I didn't compare it totally, but I found but I have inspected the code of Cilium. Currently they use Go BGP imply. They can use Go BGP implement a full the full functions. I think, and I also have tested the binary file provided by Go BGP. They can at least they can provide the function we use it. We expect in our design, like Go BGP, like eBGP. For further, maybe we use iBGP. That can be also supported for Go BGP.
Okay, I just did some quick search with Google and found there are some articles comparing different BGP solutions. Could we do a quick research here? I'm not saying Go BGP is not good, but I just want to understand better.
Sure. I can I can do a further research to compare them.
Yeah, thanks.
We have some requirements about our design. We need to ensure the reachability to the setters in remote AS from all nodes. I'll explain the reason. For the reachability of this can be achieved by the default routes on all Kubernetes nodes. If the setter like this in remote AS, but they are not accessible from these nodes by default route. There is a hack way, maybe installing the static routes. Okay. Anyway, I can explain. We can understand in later slide why the reason why this is required. We can take some example. For the first one, and this is hosted in the AS. The host will access the service with bytecode port 2. We assume that only port node 2 is selected by BGP policy. Then we can see that the service IP will be advertised to remote router, and the remote router will learn the service IP. We can see that for the request packet, the packet will go router brown, then go to Kubernetes node 2, and result S9 to port 2. For the reply packets, the destination will be this 192.18.1.1. This can be this would be forwarded where the default routes of node 2. If the packet is cannot be forwarded back to this AS where default route, the reply packets will be maybe dropped at somewhere. So that's the requirement I mentioned before. Maybe all the outsiders in this AS must be reachable in node 1 or node 2, blah blah, all this. Okay, this is the first example. For another one, is still this host delta. We want to the service, but its backend port is on another node, and only node 2 is selected by a BGP policy. The request packet go here, then reach node 2. We do S9 here, and masqueraded as the source as the IP of Antrea GW0, then through the tunnel to node 1, then to port 1, then the reply packet back to node 2, and then forward back to router, and finally back to the client delta. For node cap, it's almost the same. The only difference that then the S9 is a little more complex, but that's not important. Anyway, this can work. Okay. Another important case is about the EC. We can advertise in this case we have two nodes. The BSP policy is selected selects two nodes, and in every node the service IP will be advertised. We can see that we have two routes. We have two routes, BSP routes, in remote router to the service, and there they for they can be for host delta it can access the service where the route 1 or route 2, but as Dongson mentioned, the subsequent packets of the connection must be forwarded to node 2 always, like this link. For the first for example, for the first packet, they select the second route. Then for the third or the fifth, for the subsequent request packet, they must be always forwarded to the same node. Otherwise, connection. Oh, maybe I take the wrong example. It should be this. If a packet was forwarded to node 1, then the subsequent packet of the connection should be always forwarded to this one. Otherwise, if the subsequent packet forwarded to this, the connection will be broken because the connection is stateful in node 1.
Is there anything we need to do to support ECMP, or it's just the peer router's responsibility?
Do you mean that we need extra config or something else?
Yeah, I'm not sure. Except for advertising these IPs, do we have anything specific to support this scenario? Or it's just the router rival's responsibility?
Currently, I think it's remote router's responsibility to support the ECMP in plane of connection. We can't do anything to guarantee the connection. Maybe there's some config like session sticky or something else. I'm not sure because maybe different routers have different configs about that.
I see.
A special case. The example I used is the class IP, not an external IP or load balancer IP. Just so the example is about internal traffic policy. If the internal traffic policy is local, then only the policy will assume that the policy has only one endpoint, and this is on node 2. Then in node 1, we want to advise the service IP. Since the internal traffic policy of the service is local, it's not a reason it won't be accessible from node 1. For port side advertise, it's simple, just like this. We advertise the port side from from node 2, then ports on node 2 can be accessible from remote AS. If we want to access to port 1 from the remote AS, we need to apply maybe another or the same BGP policy with a different node selector to select node 1. Then the port setter of port 1, including port 1, will be advertised. We can see like this. Then in this AS, and the port can be reachable from the AS. For egress, it's a little different from the cases we mentioned before, because for egress case it's used to forward the reply packets back to the pod. Like this, we advertise the egress IPs. For pod 1, we use the egress IP, then it will be masqueraded with the IP address, then forwarded to the remote peers and to host data. Without BGP, we can see that if we don't have the route back to the 192 to this IP, it may be just forwarded to its default route and maybe dropped at somewhere. But if we advertise the egress IP, then it knows where it should go. It will be forwarded back to node 2, then finally back to port 2. Another case is the. Oh, sorry.
I have a question regarding the previous slide. I'm thinking, that the egress IP will be reassigned to another node, right? So
Yeah.
how quick the BGP advertisement will be, delivered to the remotes? Do you know?
That's a good question. You mean how quick the?
Yeah, I'm thinking that when the node egress IP has been assigned to, for example, node 1, I think the traffic will go from the node 1, right? But I guess the advertised routes, BGP routes might be still stated, right? Is that possible? I don't know actually, so maybe you can check that part if you haven't investigated this.
Well, that's good question. You mean that we still have some stateful connection on node 1, but the egress IP is immigrated to node 2?
Yeah, that's right. Something like that.
Sorry, I didn't thought of that, but I need to make some tests to verify this.
That's not specific to BGP. The problem even exists for ARP. I think there's no good solution unless we using connection D to copy to duplicate connections between nodes, which will be complicated.
Yeah, I guess maybe we can learn how quick the BGP policy will be advertised and know the gap here.
Okay.
Thanks.
Yeah, but again, like BGP policy, let's say, is applied on node 1 only, right? Like it is not applied on node 2. Then if egress IP changes to node 2, then I think that will not be advertised.
You will need users to use consistent node selector for egress node selector and the BGP policy selector. At least that the nodes that would be eligible for egress IPs should have egress IPs advertised. I think this also apply to service run by IPs with local traffic policy, local external traffic policy. They are two different areas, but they need to have some kind of consistency to ensure everything works.
Okay. This is the last one. Another example is that the pod is on remote node, but we only advertise but its egress IP is on the source pod of egress is on the remote node. It's nothing special. Maybe it's nothing special. Okay. That's all about the BCP proposal. Do you guys have any questions?
I don't know. Let's hear from the team if there are more questions. You already received quite a lot of questions, but maybe there are more. Let's wait a few more seconds. We are already a bit over time, but it should be okay to wait a few more seconds. In the meanwhile, Hongliang, there is just one thing that I'm not sure I understood correctly from your presentation. Are we also advertising the service cluster IPs?
Yeah.
At least in your design. Okay, but that was one of the requirements that we received, right? Because normally it's a little bit unusual to use cluster IPs outside of the cluster, but in theory, if users believe it's beneficial, why not?
I had the same question, yes, as Salvatore, but I'm convinced by the fact that there are already two other implementations already advertising cluster IP, so I'm okay with that. But I believe that advertising cluster IPs should not be enabled at the same time when external IP or advanced IPs are already advertised. I would think it's only useful when users don't have a load balancer and they want to just use cluster IP internally and externally at the same time.
Makes sense. Cluster IPs are not meant to be used outside of the clusters, but if users find it useful, then it implicitly becomes a feature.
Yeah.
Okay. So any more questions? All right. So it might be all for today. So I would like to thank first Anju and Hongliang for these presentations today. And then thanks everyone for attending. And I wish everyone a good day, good afternoon, or a good night.
Thank you. Bye.
Thank you. Bye-bye.
Bye-bye.